Cisco Secure Workload, Security Mandate, Secured SSH Access for IT and Secops teams. So let's get started. Okay, I've got two hosts here. One is a .85, the other is a .122. .85 is the asset I'm on now. I'm just going to show you IP tables, and we can see that there's some IP tables that have been inserted using Cisco Secure Workload, but there's nothing really being enforced at this point in time. We're going to go ahead and do that in a second. Next, I'm going to grep SSH for netstat, and you can see there's two hosts here, 85 and 129. They're both established connections. The goal here is to ensure that only .129 has access to any resource in the data center. It could be the cloud, it could be anything. But in this case, specifically in the data center for IT ops and NetOps folks, so they can manage these systems as needed. So I'm just going to give this a name. This is going to be a workspace, and the workspace is where we're going to build our policies and assign it to the scopes that we built in the previous video. So we're going to assign this to data center. At this point, nothing is happening. There's no assignment enforced on any asset currently. So in this case, we're going to use a catch-all policy that's allow. The reason why we're going to do that is all we're doing is trying to control access to SSH. We're not doing full micro-segmentation at this point in time. So I'm going to create an allow policy and create a new filter. And again, this is where these tags are going to come in. They're very, very handy here. I'm going to give a description of management jump boxes. And I'm going to say in this case, address equals. Here you could be a little bit more creative. You could have had a tag that you could reference. But I'm going to use this now as a filter to be able to assign policy to. And it's TCP and port 22. So you can see that here. Allow 192.168.255.129 to the data center resources. Now we could even be a little bit more creative here, and we could say if OS equals Linux, and then we could do one for RDP if OS equals Windows. In this case, I only have Linux in the lab, so I'm going to stick with that, but you get the idea. All right, and now we're going to do a deny. We're going to do it from the top or root to the data center, everything going to port 22. So essentially every IP that would be contained in root, because everything falls in there, can't access the data center through port 22, but all other ports are open and available. Now we're going to go ahead and enforce policy here. So you can see the policy, you can see all the hosts, we can load all the hosts. We've got 14 of them that we're going to apply to here. And here's a summary of policies that are currently being enforced across all the scopes. Give this a name, a reason. SSH access for IT and Secops, and policy is now enforced. Now you could do the analysis here. All right, let's do sudo IP tables -L. Let's have a peek here to see what's happening, and we're going to grep SSH. And we can see within a few minutes, we've already applied this. This is using the native capability within the operating system. And the value in that is that Windows and Linux, they all test this. It's tested, it's vetted, it works. We're not reinventing the wheel here. So you can see here, the 85 we can't connect, and the 129 we can't. Let's have a look here. The rule, obviously the outcomes we've seen here, but let's check it out here. Let's go ahead and create a filter. Filter flows, and change the timeline here, and we can see a permitted absolute. So that's our absolute policy. The asset we've connected to, consumer address of 255.129, so that's the client, and the server is 66.100, which is that P1. You can see here the port is allowed. Obviously we saw that in the example. Now let's go ahead and do .85 and let's see whether or not it is in fact rejected. And look at that, there we are. And we see an absolute deny. Pretty easy to add a layer of security within the environment that limits the adversary's ability to leverage SSH.